Yeah. Okay, so first things first, don't try learning skateboard after 40, even if you know snowboard, it will end up like this. Okay. So I will be talking about how to build your own LTE station, which is sometimes called 4G. Also talk sometimes about 5G, how you sniff traffic, how so-called IMSI catchers work, how downgrade and other attackers work. So the whole network is I don't know like how big or small it is. It was also designed for like big screen. UE is user equipment, your phone. ENB is the stuff you put on your SDR or the base station, and the backend is so-called EPC because something. And yeah, this is probably small. The simplest way to do this is so-called run project. You can use Blade RF B210, including the Chinese clones. Lime SDR works. And if you have like really shitload of money, X3010 or like the really fucking expensive SDRs, yeah, you can use. And never ever used Pluto SDR. I tried it at the beginning and it is completely broken oscillator, and it's like many months of darkness and sadness. So the radio part, what I shown of the ENB, you can make on the SDR. It will do all the transmitting, and you have to do it in the Faraday cage, ideally below ground, deeply below ground because of the levels and CTU. Yeah, as I said, phone is short UE, user equipment, and you can also emulate it by Serasaran on SDR. So you can have one Serasaran SDR to be the base station and one to be the phone. Backend is EPC. You can run it on like your normal computer, and it does stuff like routing to network, like internet and everything. And it does stuff like, in case of there is like emergency, like flooding or earthquake or whatever, there are protocols Mocno, Muran, and many others which are like kind of headache to implement. And the two useful applications for Android, you can get the information about your base stations are the Cellular Z. It was outside the Google Play. Now it's also part of Google Play. It will show you the most important part, like what kind of network is your phone connected to. PCI, that is physical cell ID. TAC, LAC is like location, and okay, it's kind of shorthand for which band the phone is operating in. Then Monster has similar function, but it has also the full database of base station coordinates from 2G to 5G. We try to get it like from the phone through root, but there is the address where you can like download the full CSV with everything, the locations and all the PCI tasks, the location information and so on. So this is how it looks like. It's like just a little small box, and I had to buy my own SIM cards because you cannot use any operator's cards because you don't know the secret key. and you need the secret key in order to go after certain step. The COTS is just commercial off the shelf, so it works on like, yeah, I have like a really old iPhone and some couple of Androids, but yeah, maybe you cannot see it. It says software radio systems run as operator. MCC is 999, which is normally operator code, and somebody said 230 today, which is surprisingly the same, and the second one is the network code 70, and 999 and 70 is like for testing. Then you have like the data cell and the other stuff around. LTE has theoretically up to 100 megabytes per second, but that's including headers and everything. With my testing, I got about 65, and you need, you know, the programmer and the PySim is like not fun thing to master, but it's necessary. And there are a couple of bizarres of 4G and LTE. So if you have no VoLTE, voice over LTE, it means all calls drop down to 2G, because the protocol most likes it like when everything goes to data, and the same thing works for SMS. If SMS doesn't go through data, it's like proper hell to implement and work around. Yeah, and how to sniff it? Well, fortunately, you have open source stress round fork. It's called LTE sniffer. If you want to sniff downlink from the base stations, you just need like one radio. If you want to sniff uplink, then you need two radios which are connected through a clock, because each need to be tuned to different frequency. And the GPS DO, it's something that synchronizes your clock to the GPS, which usually base towers use. It's ideal. It's not so expensive. It's like 160 euro or something like that. But finally, after 2G and 3G, Súdruhovia finally used AES to encrypt data instead of their proprietary ciphers. In theory, you can turn off encryption, and that works, but you can never turn off integrity. Yeah, you can with if you simulate with run the phone, but no phone will actually accept it. There are kind of bugs how the AES is used anyway, because they use counter mode. So even if you don't know like what the ciphertext is, if you flip bits, you flip bits in the plain text. So let's say you go to some site first. Usually what is the first? Let's say Google, and you time it, so you flip some bits, so it's GO1 go, and you have a certificate for it, and it can return any end results you want. And integrity is only 32 bits, despite having AES 122-bit keys. Yeah, this is like fucking small anyway, but this is like how the sniffing looks like, success rate. RNTE is like some temporary identifier. TMSI is similar. It's like the modulations. I won't go into it further, but you can correlate them together. And yes, this is something you probably won't see. Is like one phone is doing RCC connection setup. That means it has disconnected itself from a tower and is connecting itself to a new tower. And yeah, Wireshark, yeah, it's like too small anyway. But yeah, you can see everything in Wireshark, but it's a lot of data. Yeah, as I said, those two identifiers, RNTI and TMSI, should be temporary and random, but they are kind of not really, can be correlated, tracked. And when the phone loses, disconnects from a base tower, it loses security context, and it's called RCC connection release. And when it tries to connect again, it's called RCC connection setup. The one thing the phone does, it sends its IMSI, you know, the thing every SIM card has, in plain text at the beginning. So it's like very simple just to listen. And if you don't want to listen, you can actually force the attack by changing the frequency and faking the tower and something, and some IMSI or IMSI trackers do that. And this faking works until so-called security mode command, which is like fifth in the row. So first, phone sends like, here is my IMSI, and then the tower operator will assign like what keys should it use. The thing is, as I said, you can turn off encryption, but not integrity. Therefore, I had to use my own SIM card, which you can buy. It's let's say like €10 per SIM card. It's not extremely expensive, but only if you have it, you will get through the security mode. And yes, and between, sorry. And between the reconnects from one tower to another tower, the phone loses so-called security context. It can be forced. There are like so many papers and how you can attack it on subframes. It's like really insane. You can also jam all the neighboring base station, which forces to downgrade to 3G. By the way, 3G is Czech Republic doesn't exist, but it doesn't mean your box can't have 3G. So if you downgrade to 3G, you can break Kasumi, which is also known as A5 3 cipher, or downgrade to 2G, and A51 is cracked quickly. And even if you don't have any security contact, you can do like this. I think this is like big enough. You can send presidential alert to any phone that's connected to your base station, because it doesn't require anything, and it's of course used like in Taiwan or Japan for earthquakes. Yeah, and if you want to sniff it from a common car, like the box is like this big, you either have to have the keys from the operator, otherwise you will not get through the security mode command, or you have to downgrade from 5G, 4G to 3G and break the cipher there. Yeah, as I said, it's like this black box. I did not ask how much it costs, but a lot. It's in black. Maybe it should be minimally Vanta black. Antennas are placed on the top of the car, and you cannot see them unless you like look really close. And there are many other attacks, such as the bit flips, like you flip the DNS request to Google to something else, and so on, and or have NSO and similar exploits ready. Yes, and when we get to 5G, 5G is not final. 5G is like the final 7.exe, and 4G is still Gulash exe because it's also not final, but there is like disagreements in some details. The main difference in 5G is the different identity management. So SUPI is something like IMSI equivalent. It tells you the identity of the SIM card, but it shouldn't ever be transmitted over air in plain text, but it happens. It's called Scheme 0. Then they derived the second one, the SUCI, concealed identity, which is based on elliptic curves, which is like better than it was before. And there is like global identity, which is the last one, and it doesn't stay the same, and it's changed regularly. So, and 5G has so-called standalone and non-standalone mode, which in short means, yeah, we didn't want to like build all the 5G at once, and let's say we have like these 4G towers, and we want to repurpose them to 5G. It's actually like duct tape on top of their network layer. So sometimes the ethics can be shared, and I've seen a vendor who was selling the 5G mainly the middle box, and he addressed like both the standalone and non-standalone. I don't remember the details, unfortunately. So, and that's it, like all the mobile networks are a complete mess. There are like millions of shortcuts and names and everything. So that's it if you have any questions or something. Za tebou?
If you start messing around with our networks here, is it working? Yeah, if you start messing around with our networks here, like T-Mobile and stuff, like how quickly can they find out that you are doing something?
Well, if you do it like for 5 minutes, they won't. Maybe half an hour, I wouldn't be so sure, depending like where. And usually the base towers don't check for this stuff unless they detect like some long-term, you know. So I would guess other order of hours until they like catch the wind. And ČTÚ has the towers which not just for LTE or anything, like for all frequencies, which are in secret locations, like nobody will tell you where they actually are, and they are designed to detect like behavior like this. Okay, so I know it's all. Okay, thanks.